acceleration. So, I mean, all that. Now this will also have the same thing. Of course, the centripetal force also have it. Acceleration will have it what V. Now let's assume this is angle theta. Now if you look at this, the ball started from here, or the car started from here. Now here, that's the tangential force or the tangential quantities. Now when it gets to this point, it will have another tangential quantity and then others. Now let's see, we want to find the relationship. We want to find a change in velocity and expression for change in velocity, so that we can derive a formula for acceleration. Because acceleration is equal to change in velocity over change in time. It's the same as change in the v in t. Now we can extend this one. Now if you do that, we know this angle is 90. This angle is also 90 because it's a tangent. This line is a tangent. A tangent and then the radius is always 90 degrees. Now if here is 90, here is 90, then what will happen? What is the relationship between this angle and this angle? You will see that this angle is with theta plus the two 90s. So 90 plus 90 plus this, let's assume this is beta, plus beta is equal to, all of them must add up to 360, must be 360. Okay? Right. So the simple way to even remember how to get the answer, if you see that this is going to 180, so theta plus beta is equal to plus 180 is equal to 360. So that beta is equal to this 180. So that beta is equal to 360 minus 180. Theta plus beta is equal to 360 minus 180. So that we can see that beta plus theta is equal to 180. In that sense, beta is equal to 180 minus theta. So it means beta is here is equal to 180 minus theta. So if here is 180 minus theta, this whole angle is also supposed to be what? Supposed to be 180. Okay? So if we are subtracting this angle, if you subtract this one from this, we should get this angle, which is, let's say this is A. Let's say this is A. Okay? This angle that we have here is 180 minus theta. And then we are saying that this angle is A. You realize that A plus 180 minus theta must also be equal to 180. What happens? A minus theta is equal to 180 minus 0. So that you end up saying that A is equal to theta. This is what I want to do. So that this angle is the same as theta. Okay? Good. So once we get this, we are good to go. Right. So I hope I can clear now. We are seeing that we have realized that. Let me put that one on top here. We are now saying that this is the angle. Is it? This angle is theta. If here is theta. That's what I want to say. Okay, this is R. This is FT, Fnet, FC. Right, so that's what I've put in there. That's the point I want us to get. Now let's look at the next thing. So what you can just deduce is if you have an angle here and then two tangents, straight away this angle is equal to this. That can be something you can always appreciate. So let's see, let's put this in perspective. Now if you have this angle, this is FT, this is F net. Okay, which is going that way. Right. Now, if we look at the one in the triangle, this is theta. This angle is theta. This is radius. Thus, this is radius. And this is that. Because this is radius. Okay. So in that case, this radius, and this FT. They have, if this radius and this radius, they have this and this, and this and this. Then we can say that these two, if we complete this triangle, we do not know which way to go. If we complete this triangle, then of course this triangle, if this force is going that way and this going that way, this will end up going towards the center. Right, it will end up going towards the center in terms of force. Okay, then we can say that this and this are equal with the same angle. Then if this angle is the same, then we can say that this and this are also proportional. And this will be proportional to a certain force, which is the centripetal force that we are looking at. The force which is going towards the center, it is being directed towards the center. And the centripetal force we are talking about. Right. So that you see that the force here, the tangential force, and then so this is the change, the final, then, so this is not F, and this is F2. Sorry, not F2. So let's say F1, F2, because it moves from here to here. We are not looking at that. And then, so this is F2, because it's a new force. It's not the resultant that we have here. F1. Okay, so FC, that's going that way. So that we can say that the change, of course, if you want to find change, is what final minus initial. This is a final one. Okay, these are vectors. Okay, this one, the 2, as we have the let's put it, depending on the direction I'm going to look at. If you put the 2 together, this one can be like into this. So this is more or less the resultant of these two. The resultant of these two forces is that. Now, if you look at it, well, this is in terms of forces. This is in terms of distance. R is distance. So there will be a certain distance, let's say S. Now, we can also let this be in terms of velocities because it's a vector quantity. In terms of velocities, then this is going to be V2, this is V1, theta. And this is going to be the velocity towards the center. Okay, that is the resultant. Right. Then we can make an equation to relate the two and see. But before we go, let's do something small here. Acceleration is equal to v over dt. Okay? Or changing v over changing inequality t. I'll make it that. But changing t here. Right. So far as we have these two, we can then look at the relationship. We have expressed this in V. So our change is this and that is the same as saying that 2 minus 1 over change in t, which we can see, of course, we relate our to, and then that way. But let's look at this from this angle. Right. Now, so let's look at something. This triangle and this triangle, they are similar because we have said this is the theta, this V. Okay, but of course, this V and V1, they are the same, so V, and this is the same as V. So it's just like saying changing, this changing V, this V, this is V, theta, then that is R. This theta. So this should be changing what? This change in R is the same as distance, okay? It will be distance. It will be actually the R will be distance. So that is if you want to find this angle, the same as saying of course that will be the change in velocity times, or it will be your velocity. Let me put it this way. So far as this is supposed to be a distance. This is distance, this is distance. So this is, if you want to find distance, distance is equal to velocity times what? Time. Okay? Or the same as, because velocity is constant here, R is constant, you can say V times change in t. Okay? Because this will give us a distance. Assuming this is distance, then this distance will be going to be what? Your velocity times what? Your time. That will give you distance. Distance is equal to velocity times time. But this V is constant, so that is why we didn't have change in V. So it's t will be changing t. Okay, this is changing v. Right. Okay, so that will be the velocity for this whole thing is v, right? Okay, so that is what we have now. Because there are two similar triangles, we can say that let okay v, this v over change in v should be equal to, because they are similar triangles. If we divide this by that, then this divided by that should also give the same r over v change in t. This is the expression I want us to get, right? Because many times change in t will give us the distance, okay? And this is just change in t. Okay. So in that case, we're going to have let's rearrange and see. This is the same as saying v can come in by, so we have v squared. And then this can cross to this. So, and then let's put the r's here, let's say here.